Today I'm going to try to explain counting sort intuitively. Many of us get confused how counting sort works because the steps involved are kind of like, do this and that, and we know, okay, it's going to end up sorting the array, but we just don't understand like why it works, right? 1 plus 1 is very easy to understand that it equals 2, but a squared plus b squared equals c squared. We know that if you try it on any right triangle, it will work. But why? Why does it work? What's the proof? What's the intuition behind it? So that's what I'm going to try to explain here instead of just explaining the steps that are involved of in counting sort. I will do that, and I will add an additional intuitive explanation, or at least I'll try. Okay, so let's examine the problem here. We have an array that has 7 elements, 5, 1, 3, 7, 2, 9. Oh, it's actually 6. Let me just make that 7. Okay. Let me make that 7 elements. So let's say we have 3 and 5. Okay. So we have an array of 7 elements. Okay, the size of this array is 7. 1, 2, 3, 4, 5, 6, 7. Now, the range of this array is 0 through 9. So counting sort always involves another array. It always involves another array to store the frequency of each item. And each item maps to an index in the range array. And this is crucial and essential for counting sort because it's how we map the items to their final index when we sort. And I'll explain everything in intuitive, detailed steps. Okay, so the first steps, you just got to take it as a given, and you'll understand how everything pieces together at the end of this video. So the first step is to create a range array. And the range array is basically described as the maximum value in the array. So the maximum value in this array is 9. If this would have been 100, then the range array would be of size 100. So the size of this range array is going to be 9. And what we have over here is a range array. And I'm just going to do it somewhere else. Okay. The range array is of size 9. That means we're going to have, it's really of size 10, actually, I should say. It's of size 10, but its range is 0 to 9. That means we're going to have 10 elements, and the amount of indices are 9, with 0 included, which makes 10. So 0, if you count it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the index mapping to each value in this range array. So the first step is to, and let me just explain abstractly, the goal of counting sort is basically to map every single value in the original array, and we want to map it to a position in the range array. And this is basically a prerequisite for creating a sorted array. Okay, so this is the first step. So this is a prerequisite. Think of this as a prerequisite. We kind of order our information and prepare it to sort. Okay, so there's kind of 2 main steps here. The first step is to basically map every single item. 5 maps to this, 3 maps to this index, 1 maps to that index, 3 maps to this index again, 7 to that, 2 to that, 9 to that, so on and so forth. And basically what we want to do is record how many times each item exists in the original array. How do we do that? By just simply putting a 1 and adding if the frequency of that item goes up. So the only time where we have a higher frequency of 1 is for the number 3. So every single item over here that is referenced in this array will have 1. 3, however, will have 2. So let me just show that visually. So we start with 5. So I'm just going to erase 5, and I'm going to put in 1. Okay. Then we go on to 3, and 3 is going to be 1 for now. However, it's eventually going to be 2 because we're going to keep on iterating and get to the second 3. But we'll leave it 1 for now to show you a step-by-step process. Then we go to 1 and we erase the value at index 1, and we're just going to put a 1 there, right? 1 just basically means it's, you shouldn't get confused that 1, we're putting this 1 here. 1 just means that we only have one time referencing this value. So it kind of swaps over here. In the range array, the indices refer to the values in the value array, in the actual array that we're trying to sort. So that could be a bit confusing. And the values in the range array just represents the frequency. So it's kind of like some sort of abstraction as a prerequisite for count sort. Okay, so then we go on to 3. And as we said earlier, that becomes a 2 because now we have 2 times 3 in our value array. And we go on to 7, and we're going to take that away and make it a 1. And then we go on to 2, and we're going to make that a 1. And we go on to 9, that maps to this index. And then we want to record the frequency of 9, which is again 1. Okay, so this is the prerequisite for count sort. We have a bunch of values, and these values map, or these values contain the frequency of their corresponding index. And the index of this array corresponds to the value, to a value or item in the original array. Okay, now what do we want to do? How do we take all this information right now and create a sorted array? So what we want to do is basically, we want to somehow figure out where are we going to place what? Now, if you look very carefully, adding all the frequencies of every single item in this array will equal the size. And we could just prove that over here, right? 1 plus 1 plus 1 plus 1, right? This means that we have 2 items, right? We have 2 3s, so that's going to be a total of 4. 1 plus 1 plus 2. Plus 1, which is 5, plus 1, which is 6, plus 1, which is 7. That equals the size over here. Okay? So essentially, if we keep on adding left to right, each number, okay, eventually the last number will be at the highest index. That means we want to somehow map 9 to item 7. Okay, and how do we do that? So the answer is, intuitively, we will be able to do that by simply adding each number to the next in the range array, and at the end, we're going to simply get a value of 7, or of the size of the array, that will map to the last index, which is desired because that is sorted. And then each value, hopefully, right, we'll see. Hopefully that what will happen is that each value will map to a index. It will map to the desired index in the original value array. Now that happens when we go left to right. And when we accumulate, when we simply add left to right. Now let's show this by example. We could ignore the zeros. Now the reason why we have to store a 0 for 4, first of all, this array is contiguous. So we could essentially use a hash map, but I want to show an array in this example. We could use a hash map, but in order for this example, where we're using an array, we're going to have to propagate the total accumulated values in the previous values, and we're going to have to propagate it, even though it's just wasting space. But it's not really wasting space, right? Because 0 is still holding 4 bytes or whatever it is. We're just filling that with a number, but we need to propagate that value downwards, and so that the next value, which actually has an item in the array, knows where to put that in the original array. Which index should it go to? Okay, so it may seem a little bit confusing at first, but let's go ahead and let me paste this scenario. Okay, so we start with 0. Now 0 is 0, right? So we're going to try to add 0 to 1, and that turns into 1, okay? So it's just simply 1, okay? Then we're going to take this number and try to add it to the next. Okay, so we're going to take, well, how many frequencies of 1 do I have? I only have 1. So I know automatically, right, in my array, this is going to be the first item. 1 is going to be the first item. The next item is going to be above 1 because I don't have any more frequencies. I don't have any more 1s to go through. So I know automatically that the next item, right, which is 2 in this case, that has a count, that has a frequency, is automatically going to be the item after 1. So essentially, we can know that intuitively, but in code what we're going to do is we're going to add this 1 to this. And what's going to happen is the 2 over here will basically hold a new value called 2. And that 2, and what's going to happen is that this, we're going to do it again. We're going to simply take this index and we're going to add it to the next. And we do this over and over, and that basically tells us where each item has to be, okay? And 2 plus 2 is 4. Okay, now this is 0. And that is, we just need to propagate that value so any other items above 4 can know about where their index has to be, starting from where. So 5 is just going to be 4 plus 1, which is 5. And again, we have to propagate it. Okay, so we're just going to fill that in. 5 plus 0 is 0. 5 plus 1 is 6. And, oops, 5 plus 1 is, 1 second. 5 plus 1 is 6. And 6 plus 5 is, no, I'm sorry, 6 plus 0 is 6. See, we just have to propagate it. We have no 8 over here, so, but we just have to propagate in the case that we had 8, right, it would be 7, right? But now that it's 0, it's just 6. And the last value is 7. So basically, what we just did here, okay, this is 1. What we just did here is basically created in our range array, we kind of created in our range array where each item has to be, okay? And remember what we said earlier in this video, that 9 maps to index 7. Using this method of simply incrementing value by value, we will get the index of each item to be mapped. That's basically it. I will try to explain this in another way. Let's say if I have, blocks of 3. Let's say if I have a couple of blocks, okay? I have this block, that's 1, 2, 3, 4, 5. This block has 5 ones, okay? So this is 5. This block has, 1 second. This block over here has, let's say, 3. All right. It has 4 3s, right? So then I have another block that, let's say, has 2 10s. Okay? How do I know? How can I kind of calculate where the 10s are going to be located? So assuming we have all these blocks in sorted order, 1 1 1 3 3 3 10 10, right? If I have a mapping, right? of ones, and I say all these ones, right, have maps to 5, and all these 3's map to 4 3's, and all these 10's map to 2 10's, right? So how do I want to know, how do I figure out where 3 is going to be mapped to? Or the last 3, right? How do I know where 10 is going to be mapped to? The answer is I got to take the mappings of the items before 10. I got to take the mappings or the index locations, whatever you want to call it. I got to take the mappings of the second item before 10, and I got to add them together, and that's where I get the minimum position needed to index 10. And I could show you that in an example, right? We have over here, we have 1, 2, 3, 4, 5. Okay, that references this over here. And then if we add on 4, we have 1, 2, 3, 4. This over here has a total of 9 elements. That means 10 is going to be the 9th element if you're indexing with 0, right? This has 9 elements. That means this is the 8th index. This is 0, 1, 2, 3, 4, 5, 6, 7, 8. That means 10 is going to be 5 plus 4. It's going to be mapped to that index. Now, we only know that if we keep on adding everything from left to right. So the same example is over here. The same example is over here. We keep on adding left to right. We keep on adding. So 1 plus 2, and then we add plus 4, this. We keep on adding until we know exactly where each item has to be. And it just works out that way because we mapped every single thing with their frequency. We mapped everything to in order. And it works because arrays are indexed in order. And if we map everything in order and we add everything in order, we will get the correct index for each item. And that's basically how it works. So that's basically how it works. So to sum up, let's just do this calculation. We basically take 0. This turns into, it's 1. We took 1 plus 1, 2. We took 3. We took 2 plus 2, which was 4. We took 1. We took 0. There's no 4 here, so we took 0 plus 4, and we keep on adding, and we kind of get the index of which item of where it should be. Okay. Now, how do we actually map this into the final array? So how do we do that? Okay. So what we do is we basically start with every single item. Okay, and we start again. We iterate again, and we say, okay, where do I want to put this item? So again, where do I want to put 5? And let's say, assuming we have a new array, and where do I want to put 5? So I go to 5, I go to its index 5, and I see where is it going to be located. Okay, and it's going to be located at position 5, right? And since the array size is 7, and we have 6 indices, so it's position 5 minus 1. So if I have 0, 1, 2, 3, 4, 5, so 5 is going to be located here. Then I go on to 3. Where is that going to be located? Well, okay, also what I want to do, I want to decrease this by 1. And the reason is because if I references this again, I don't want to replace, right? If I have 2 5s, I don't want to replace it. So what I want to do is I want to put it right under the previous 5. So that's why I want to minus it. So like this, when if I ever encounter 5 again in this array, I'm going to know, and I'm going to say, oh, okay, we have a 5 here. Oh, so now I know where to put it. And I'm going to put it right before the previous index, which was 5. Now it's 4. Okay, and we're going to need that, by the way, for 3, right? Because 3 has a frequency of 2. So we're going to need to decrease the index of 3 by a certain amount, which is 1. And therefore, we're going to be able to remember, quote unquote, how we indexed that item before and where should we do it now. Okay, let's continue. So now we have 3, right? So 3 maps to 4. And remember, we're going to take 4 minus 1 because it's we're trying to map to indices, which indices start from 0, and so we're going to do 4 minus 1, so 3, 0, 1, 2, 3. 3 is going to be here. Now we want to erase this. We want to erase this, and we want to put in a 3, showing that we used index 4, or position 4, for 3. Meaning if we ever have a 3 again, which we do, we will put it at this position, okay? Right here. So I'm just going to wait till we continue and find 3 again. Okay, now we're going to go to the next one, 1. 1 maps to, we have here 1. We see its value, it maps to 1. And remember, we can do 1 minus 1 to get the index. 1 is the position, the index is 0. And we will see that we place it over here. Okay, so let's just put a 1 in the 0. We continue, we go to 3. Now what's 3? Again, we go to 3. We see 3 is mapped to 3, and we're going to just take 3 minus 2, which is 0, 1, 2. We put in 3 here. Now we're going to go to 7. And we go to 7 and we say, okay, let's go to 7 here. We see 7 is mapped to index 6. Where is that going to be in our count array? That's going to be at so I'm sorry actually. This 5 over here, right? This was 5. This was 5. I forgot to minus it by 1, and that's what I had to do. I had to minus it by 1. So this 5 should really be here. 0, 1, 2, 3, 4. Because I have to minus to get the index. So this was 4 as we showed, but I don't know why I put it here. Okay, so now again we're up to 7. 6 minus 1 is 5, and we're just going to do 0, 1, 2, 3, 4, 5, 6. So 6 minus 1 is 5. We're going to put 7 here. Then we go to 2. 2 is indexed over here, and its position is 2. And we want to minus that by 1 to get the index, so that's 0, 1, 2 is here, and then we want to go to the last number, which is 9. We get to 9 over here, the position is 7, and we minus that by 1 to get the index, which is 6, and we put a 9 here. So that's how count sort basically works. The confusing step might be, how do we find the correct position, and why do we add left to right? And the answer is basically we want to all the frequencies over here total to the amount of positions available in the original array. So if we just keep on adding left to right, we're going to get each position for each item, and that's basically how it is. It just works out that way because the array is contiguous, and we add everything in proper order. It's like, imagine if this whole entire array, let me erase all this. Imagine if all this was a bunch of 1s, right? Imagine it was a bunch of 1s. 1, 1, 1, 1, 1, 1, 1. So what this would mean is that each index over here, each value has at least 1 placement in the array. So imagine this array was. I'm just giving another example. It's a very quick example. So I just want to show and be clear. So imagine this was not size 7. Let's say this was of size, it was size 10 or 9, right? And what we're going to do is just say, let's say we have a number 7 here, we have a number 6, we have a number 1, we have a number 3, we have a number 2, or let's say 4, 2, and 9, and 8. Did I miss any number? Yes, I missed one number. Oh, 0. Okay, so assuming we have all these numbers, right, each thing is going to be mapped to a value, right? So this whole, the range array is going to be filled with a bunch of 1s, right? So if we just add everything left to right, we're just going to come out with something like this. 1, 2, 3, 3, and the next one is going to be 4. I'm just going to erase everything here. We're going to come out with something like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it comes out this way because everything is contiguous, right? We keep on adding left to right, and we know that the index all the way at the right is the highest value. So if adding all the frequencies of all the items all the way before that item will be the position for that item, and that applies to any element in this index array because they're all sorted. So just this is like a kind of I think I gave an intuitive approach to this example, to the count sort. Now, of course, my just to add a side note, I didn't my version was not a stable version because I started from the beginning. Stable means just if equal items were in the original order. If you want it to be stable, you have to start at the end, or there's other methods. Instead of decrementing, you increment. But this is just to show like give an intuitive sense of why we add left to right and why it makes sense based on our structure of storing frequencies for each item that's mapped to a certain index and that's referenced in this array. And doing that will basically yield the position corresponding to each item and will give us our final array. Okay, thank you for watching. Hope you understood and hope I cleared many doubts.